Saxon Algebra 1, Lesson 42. We're going to play a fun little game today. It's called Solving Multivariable Equations, which sounds really complicated, but this isn't all that complicated. You pretty much know how to do it already. Here's the thing. I'm going to show you an equation. It's an equation because it has an equal sign. It's an equation because it has an equal sign, but it's got multiple variables. It's got a y and an x and a z. That's a z. I make my z's like that so they don't look like 2's. Have we had this talk? My 2's look like that, but sometimes they look like that. Yeah, and that looks like a z. So my z's I always make like that. Okay, this has multiple variables. A cool rule about algebra is that if you've got multiple variables, you need one equation for every different letter you're trying to solve for, if you want to find values for them all. We only have one equation, so there's no way, there's no way we're going to get a value, but John tells us this: solve for y. Those are his instructions, and then he gives us that. What that means is get the y by itself on one side of the equation and push everything else to the other side. Don't even worry about it. It won't be a neat, pretty clean answer, but that's what I want you to do. So what we do is we look for the letter, and we're just going to send everything else to the other side. So I want this by itself over here. That means I better add the x and subtract the z, right, to cancel them out. That'll cancel, and I'm going to get 6y equals 4 plus x minus z. Remember, we have to do the opposite operation for each of those, right? Okay, that went a long way in getting my answer cleaned up, but I still have a 6 hanging around. How am I going to get rid of the 6? Well, the 6 is being multiplied, so that means I have to divide every term, not just once on each side. Well, technically it is once on each side, but we have to do it separately for each term. This cancels, and for my final answer, I get y equals, this is reduced, 2/3 plus x over 6 minus z over 6. That's our final answer. It's not, like I said, the most satisfying simple answer, but it is a solution. Okay, because we solved it for y. And this is a step we're going to be doing a lot in other kinds of problems, so don't worry, it'll be applicable. Let's try another one. Solve for y. John has to tell us what to solve for, or we don't know where to even begin in a problem like this. Ready? Okay, so we're solving for y. So the first thing we do is take a look at this and go, where is our y? Well, interesting, we have 2 y's. So we have to smush them together and get everybody else on the other side. All right, how should we do that? Well, I look at the equal sign there. I go, okay, which is going to be easier? Is it going to be easier to work with this y and get rid of that and bring this one over? Or should I try to collect the y's over here? Well, I think it'd be easier to make the changes on this side, because if I add 2y, that will swim the y fishes over there. And then if I add 4, that will swim the plain number fishes to the other side. See how I'm thinking that through? First, I decide to put my y's here, and then I take the 4 and move it out. That cancels, and I get 4x plus 6 equals 3y. Oh, okay. I feel good about that. We're almost there, right? Now all I have to do is just get rid of this 3 And remember, my goal is always to get the desired letter by itself. I always write the letter I'm solving for over here and circle it so it stays in my mind, is what I'm trying to do. Now as I write my final answer down, I'm just going to reverse the order. I'm going to bring this over here and I'm going to say y, because that cancels, equals 4/3 times x plus, this will reduce to 2. Yay! Beautiful, right? I love it. A couple more. There is not another topic in this lesson. There are just 1, 2, 3 more problems to go. Let's hope there's something exciting. Solve for p. All right. Okay. We take a look at it. Yeah, it's an equation, so that means we're going to be swimming fish back and forth. We're solving for p. Where are our p variables? There's one and there's one. Which way do we want to swim the fish to get the p guys collected on one side? Now, I will remind you of this. There's not a wrong answer. You can swim them either way and it'll be fine. It's just a question of which is easier. I would rather go over here again, because now I only have to get rid of this one and bring one over. Here I would have to get rid of 2 things. So, but let's just do it that way, just for fun. All right, so I'm going to bring the p's over to this side. So I'm going to subtract this p, and then I'm going to have to swim these to go away, right? And I do the opposite operation. I'm adding 2a, so I subtract. I'm subtracting 5, so I add. I have to do the same thing here. And then I'll squeeze the plus 5 there. I don't have a lot of room. Okay, so I canceled this. I canceled this. I canceled that. So now I'll get 3p equals, give myself a little more room, 4a plus 5. What do you think? So far, so good, right? And then our last step is to get rid of this number that's clinging to the outside of p. Best friend, I'm sorry, you have to go home. P equals, now there's 2 stylistic choices that you can choose between here. You can write it like this, where the a is part of the numerator, and then we have a denominator, or you can write it where the fraction is kind of separated and the variable, the letter, floats. I know where John is going with this. We're going to a place where this is going to be a super helpful presentation, but normally I would say don't have floating letters. Get your letter in the fraction club, and it belongs in the numerator. So I would say either style is fine. For now, I want you to really stick true to that rule that we don't have floating letters. But later you'll understand why we sometimes want our letter to float and why there's a purpose to this presentation. For now, either way is fine. All right, ready? 42.4. This one is a mile long. Well, I mean, maybe not a mile. Solve for x, John tells us. It's pretty long. I'll check it. Okay, we're solving for x. I only see one x term, it's right there. Oh no, there's 2. There's another one. And the equal sign is right there. That means all of these fish are clustered on this side of the coral reef, if you will. My Finding Nemo metaphor just kicked in. We can combine these without having to swim anybody across the reef. So we can combine these 2 x's and we'll get 4x. And we can combine the y terms and we'll have 3y, positive 3y. And then this stays by itself. So remember that we swim fish when we're trying to get them to cross the equal sign. But if they're on the same side of the equal sign, we can just add them as like terms, okay? Two different things. That is very easy to get confused about. It all depends on where the equal sign is relative to what you want to combine. But these guys are all on the same side of the coral reef, and so we can just mush them all together. Okay, 4x plus 3y minus 4 equals 0. Now we're supposed to be solving for x. So that means these guys are going to have to hit the road, right? We want to keep this here. So let's subtract 3y and add 4. Again, opposites. Minus 3y and plus 4. Make sure you're choosing my presentation style exactly. These cancel. We get 4x equals minus 3y plus 4. And then we divide, right? Because we want that x by itself. And it looks like you're making a big mess, but here's the thing. It's fine. X equals minus 3y over 4 plus, look, this simplifies to just 1. So this is good. Again, with this presentation style, John tends to make a floaty letter here, like this. Until you understand why that might be desirable, I would just assume you're not. This is correct. So sloppy. One more, and then we're done. Kaboom. Ready? Example 42.5, we are solving for y. Remember, John has to tell us, or we have no idea what he wants us to do. 4y plus 6x minus 4 equals 2. All right, there's our equal sign. So we pay attention to where our fish are. Are they on the same side of the reef, or do we have to swim them across? Here's our y. That's what we're solving for. So we might as well get these guys out of town, right? These two are going to go together. I should have written that 4 closer to the 2, but I didn't. Cancel-y, cancel-y. 4y equals, that'll be minus 6x plus 6. Those are the two that combine, right? And now for the last step, get that y by itself by dividing. And we get y equals, and then I can reduce these in my head, minus 3x over 2 plus 3 over 2. Yay. I just want to show you what John did that looks ever so slightly differently. When he swam these fish across just like we did, but when he wrote them down, he wrote 6, he wrote that first, minus 6x. So his answer is in the opposite order. He has y equals 3/2 minus 3x over 2. This is the same, because in addition, order doesn't count, right? 3 plus 2 is the same as 2 plus 3. Order doesn't matter. So as long as the signs are proper, which they are, right? Because the 3/2 is positive and the 3x over 2 is negative, we're good. Okay, that's lesson 42. I hope that was fun. I hope you enjoyed it. I'll go that far. I'll say, I hope you enjoyed it, and I will see you next time. Goodbye.